Hello again. We are going to learn about the chain rules some more today. So this lesson is kind of a continuation of our last lesson on the chain rule. We technically could skip this and not do this, but I like to go through this with students just so we get some extra practice on the chain rule and a few of the other rules that we've talked about as we're leading into our second test on derivatives, basic derivatives, mechanics. So we'll get started. It says determine the derivatives for each of the following. Simplify your answers. So x times the natural log of x. This actually is not a composition of functions. This is a product of two functions. We have the function x multiplied by the natural log of x. So this is like our u and this is like our v. So we're going to apply the product rule in order to find the derivative for this one. So I'm going to copy the first function u and multiply it by the derivative of the second function natural log of x. You should have natural log of x on your note cards. The derivative of the natural log of x is 1 over x. And then we're going to have plus, copy the second function, natural log of x, and multiply it by the derivative of the first function, 1. The derivative of x is 1. So now it says to simplify your answers. So x times 1 over x simplifies to just 1. And then plus the natural log of x. That's our answer. Number 1 is done. Okay, number 2. F of x is equal to the natural log of the quantity x squared plus 1. So this one is a chain rule problem because we have a composition of functions. The outside function is the natural log. The inside function is x squared plus 1. So from last time's lesson, in order to take the derivative, we're going to start by taking the derivative of the outside function. The derivative of natural log of x is 1 over x. We just talked about that in the last problem. But instead of x, we are using the inside function in the place of the x, copied down. So 1 over x squared plus 1. So we did the derivative of the outside function and we copied the inside function, still inside. And then we're going to multiply by the derivative of the inside function, and the derivative of x squared plus 1 is equal to 2x. And to simplify this, there's no common factors in the top and the bottom, so we just write 2x over x squared plus 1, and that one is done. All right, number 3 says f of x is equal to the natural log of the cosine of x. So to take the derivative, we're going to do it like we did the last one, chain rule problem. The derivative of natural log of x, the outside function, is 1 over x, but in the place of the x, we're copying the inside function, so 1 over the cosine of x. And then we're going to multiply by the derivative of that inside function, cosine of x. And the derivative of cosine of x is negative sine of x. Now, to simplify this, you have negative sine of x over the cosine of x, which can be written using the quotient identity from trig, from pre-cal. Negative sine of x divided by cosine of x would be negative tangent of x. Okay. All right, number 4 says f of x is equal to 2 to the x power. So this is another note card that you have in your note card stack. It is the b to the x note card. The derivative of b to the x, where b is any base on that x. So the derivative of b to the x is equal to b to the x times the natural log of b. That's one of your note cards. So the derivative of 2 to the x is 2 to the x times the natural log of 2. And that one is done. Number 5, f of x is equal to 5 to the power of x cubed minus 2x. This one is like number 4, except for we have an inside function in the place of the x. So this is a chain rule problem. So we're going to take the derivative of the outside function, which is 5 to the x power. And in the place of the x, we're going to copy the inside function. So it's 5 to the x, which is the inside function copied in its place, times the natural log of 5. And then we have to multiply by the derivative of the inside function, which is 3x squared minus 2. And that can't be simplified really any further. It wouldn't really benefit us any to distribute that natural log of 5. It's probably most simplified as it's written in its factored form. Okay, number 6 is a lot like number 3, except for it's kind of like a double chain rule problem. We have y equals the log of the cosine squared of x. So let's break this down. Y prime is equal to the derivative of the outside function, the log of x, is 1 over, normally in the note card it's x here, but in the place of x we're going to put our inside function, copying that inside function. So 1 over x times the natural log of the base on the log, which when there's no base on an log log, that's base 10. And then we have to multiply that times the derivative of the inside function. Now, Mrs. Heiss, why did you write ddx of cosine squared of x instead of just taking the derivative? Well, the reason that I did that is because this inside function is really like the cosine of x quantity squared, and it is like a chain rule problem in itself. So we have to apply the chain rule twice on this problem. How exciting. So we're going to go 1 over the cosine squared of x, natural log of 10, and then to take the derivative of this, we have the outside function x squared, so our 2 comes out in front. We copy the inside function, subtract 1 from the power, so now it's a 1, and then we multiply by the derivative of the inside function. The derivative of the cosine of x is negative sine of x. And now we have finished taking the derivative, but it is not simplified. So I'm going to simplify it by putting basically all of this that's being multiplied times our fraction over 1, so it's going to go into the numerator. So I'll have negative 2 cosine x sine x in the numerator over cosine squared of x natural log of 10. Now, do you notice we have a common factor in the numerator and the denominator, that being the cosine of x? That can divide out. So now we've got negative 2 sine x over cosine x natural log of 10, because the square is gone because we canceled one of the cosines with the cosine in the numerator. And now if you take sine over cosine, just like we talked about in problem 3 above, that is equal to the tangent. So we could simplify it a little bit more, saying negative 2 tangent of x over the natural log of 10. And then that is as simplified as it can go. We're done. How exciting. All right, the next problems say, determine the derivatives for each of the following. Do not simplify your answers, which is great because we don't have to do any simplifying. We just have to figure out how to take the derivative and then call it done. Now, why did they do that? Well, these problems are a little bit more involved. Sorry to break the news to you, but we can do it because we have awesome math powers. Okay. Number 7, f of x is equal to x squared times the square root of 1 minus x squared. So we want to think of that square root of 1 minus x squared as, in parentheses, 1 minus x squared raised to the 1/2 power. That way we're going to be able to use the power rule. So this is a product of two functions. We have the x squared function, and then we have this composition of functions for our second one. So we're going to start with the product rule. Copy the first function, x squared. Multiply it by the derivative of the second function. Well, to take the derivative of this, you're going to have to use the chain rule. The outside function is x to the 1/2, so the 1/2 is going to come out in front. Then I'm going to copy the inside function, still inside, and subtract 1 from the power. 1/2 minus 1 gives us -1/2. And then I'm going to multiply by the derivative of the inside function. So the derivative of 1 minus x squared, derivative of 1 is 0, derivative of -x squared is -2 comes down in front, x to the first power. And now, all this was copy the first function, multiply by the derivative of the second function. Now I'm going to add to that the second function copy down, and since I'm not taking the derivative, I could just leave it the way it originally was. Or I could write it the way we have it here. Either way is fine. And then times the derivative of the first function, x squared's derivative is 2x. And that is the answer. Since it says do not simplify, we just leave it like that. All right, number 8, f prime of x. We're taking the derivative. So this is a composition of functions. So we're going to use the chain rule. The outside function is like x cubed. So I'm going to pull the 3 down in front, copy the inside function in its place, subtract 1 from the power, so 3 minus 1 gives me 2, and now I have to multiply by the derivative of the inside function. In order to take the derivative of that inside function, we have to use the quotient rule. Woohoo! So start with the denominator, x squared plus 3, multiply by the derivative of the numerator, which is, let's see, the derivative of 3x minus 1 is just plain old 3, minus the numerator copied down, 3x minus 1, times the derivative of the denominator, which is 2x, all divided by the denominator squared. And that's it. That one's done since it said do not simplify. Now we are on to number 9. We are going to take the derivative, but do you see how it has this little 4 between the sign and the argument of the sign? Let's think of this as the sign of 3x squared plus 1 quantity to the 4th. So this is kind of another one of these double chain rule problems. So we're going to bring the 4 down. B prime of x is equal to 4. We're going to copy the inside function, subtract 1 from the power, so that's a 3, and then we're going to multiply by the derivative of the inside function. And why did I do that? Because this is a composition of functions here, and I have to use the chain rule as well. You don't have to do this little ddx of the sign of 3x squared plus 1, but I find that if you do this when you recognize the inside function is a composition of functions and will require the chain rule, it helps you to make sure that you kind of don't miss anything when you're taking that next derivative in the problem. So the stuff in front is just going to be copied down. We don't do anything to it. And now I'm going to take the derivative of that inside function. So sine, derivative of sine is cosine. Copy the inside function, and then multiply times the derivative of the inside function, which would be 6x. And now we're done, since we don't have to simplify. All right, number 10. M prime of x is equal to. All right, this one, again, let's think of it as 5 times the cosine of 4x cubed. That little cube in here, it's helpful to think of it as being outside because that's actually part of our outside function. So the 3 gets multiplied by the 5, which will be 15. Copy the inside function. Subtract 1 from the 3, which gives us a 2. And then we're going to multiply times the derivative of the inside function cosine of 4x, which is a composite function, a composition of functions. So we have to use the chain rule again. So m prime of x is equal to 15 times the cosine of 4x squared. The derivative of the cosine is the negative sign. Copy the inside function and then multiply by the derivative of that inside function 4x, which would just be 4. And that one is now done. Okay, moving down to number 11. Here we have a cube root, so I want to think of this as the sine of 4x raised to the power of 1/3. So y prime will equal, the 1/3 comes down in front. I'm going to copy the inside function. I'm going to subtract 1 from the power, so 1/3 minus 1 is negative 2/3. And then I'm going to multiply by the derivative of the inside function, sine of 4x, which again is a composition of functions and will require the chain rule for that. So y prime is equal to this beginning stuff. We just copy down, we don't mess with it. We're just working on, the derivative of this. Does that look negative? My apologies. Derivative of this inside function. So the derivative of sine is cosine. Copy the inside function, multiply by the derivative of that inside function 4x, which is 4. All right, number 12. This one says if f of x is equal to 3x times the sine of 4x, find f prime of 0. So we're actually going to have a numerical answer this time. We will find the derivative first, and after we find the derivative, we'll substitute 0 in for the x's. So to find the derivative, we're going to think of this as a product. The first function is 3x, the second function is the sine of 4x, so this is our u and this is our v for our product rule. So f prime of x is equal to, I'm going to copy the first function, 3x, and then multiply it by the derivative of the second function. The derivative of sine is negative cosine. Copy the inside function, multiply by the derivative of the inside function 4x, which is 4. Plus, now I'm going to copy the second function, sine of 4x, and multiply it by the derivative of 3x, which is 3. And now I sub in zeros for all the x's. 3 times 0, negative cosine of 4 times 0 times 4, plus sine of 4 times 0 times 3. Okay. This big 3 times 0 in front is going to be 0 times all of that, so my first term is just 0. Plus, this is the sine of 0. From your unit circle, the angle 0 is to the right of the origin, and the sine is the y-coordinate, so that's 1 unit to the right for the x, which is the cosine, and 0 for the y, which is the sine. So the sine of 0 is 0, times 3 is 0, so we have f prime of 0 is equal to 0. All right, moving on to the back. We have a fun problem to do next. Super fun. What is the derivative of f of g of h of m of x? Whoa! No numbers? Crazy. Okay, so we're going to obviously use the chain rule here on this problem. And the way we're going to do it is start by taking the derivative of the outside function. F prime is the derivative of f. And then we're going to copy the inside function. One, two, three, four closing parentheses. And then we have to multiply times the derivative of the inside function. 1, 2, 3. Make sure all my parentheses are closed properly. There we go. Okay, now everything that's in front is just staying in front. Nothing in front will be altered or changed in any way. And now we'll take the derivative of this. So we're going to start by taking the derivative of the outside function g. So that's g prime. And then we'll copy the inside function. And then we will multiply that times the derivative of the inside function h of m of x. Okay, everything that's in front of the d dx, we're just copying down. And now we're going to take the derivative of h of m of x. So the derivative of the outside function. Okay. Copy the inside function. Oops. And then we're going to multiply by the derivative of the inside function, m of x. Now, we copy everything that's in front. And now all that's left inside is m of x. That is not a composition of functions. That's like f of x. The derivative of f of x is f prime of x. The derivative of m of x is m prime of x. The inside function here is just x, whose derivative is 1. So if you were to multiply by the derivative of the inside function now, it'd just be times 1. So we don't do that. We're done. This is the answer to the problem. We took the derivative of that giant composition of functions. And we're done. Okay, doesn't that feel good? Number 14. F of x is equal to the quantity 1 plus cosine squared of x raised to the 6th power. So f prime of x is equal to, we're going to bring the 6 down in front. Copy the inside function. Now, cosine squared of x, remember, means cosine of x quantity squared. And then we're going to subtract 1 from the power, so bring that down to a 5. And then we have to multiply times the derivative of the inside function 1 plus the cosine of x quantity squared. So the stuff that's in front just gets brought down. And we could even write that cosine squared of x. It's inside the parentheses and it's not changing any, so we're kind of done with that. Now, the derivative of 1 plus the cosine of x quantity squared, the derivative of 1 is 0, so you can just put a 0 plus, or you don't have to write that at all. This next part, cosine of x squared, is a chain rule problem, so we'll bring the 2 down in front, copy the inside function, subtract 1 from the power, and then multiply times the derivative of the inside function. The derivative of cosine is negative sine of x. And that one is done also. You don't have to simplify on these, so I'm just going to stop there. All right, the next one, 15. Y is equal to the tangent of x squared plus the tangent squared of x. That's kind of interesting. The square kind of floats. Y prime is equal to, okay, first one's a composition of functions. The outside function's the tangent. So the derivative of the tangent is the secant squared of x, but we're copying the inside function, and then we're going to multiply, pardon me, by the derivative of the inside function x squared. And that takes care of the derivative of the first term, plus the next one is tangent squared of x, which is like the tangent of x quantity squared. So the 2 comes down in front, tangent of x to the first power, and then times the derivative of the tangent of x. So y prime is equal to the secant squared of x squared times the derivative of x squared, which is 2x, plus 2 tangent of x times the derivative of tangent of x, which is secant squared of x. And that one is done. All right, number 6 is y equals the sine of the quantity 1 over x plus 2. So the outside function is sine, derivative of sine is cosine. We'll copy the inside function, and then we'll multiply by the derivative of the inside function, 1 over x plus 2. Which you can do 2 different ways. You can take the derivative of that using the quotient rule, which is probably the longer way to do it, or you can think of it as x plus 2 raised to the negative 1 power, since it's just a numerator of 1, and that would employ the chain rule for that derivative, and then we don't have to mess with the quotient rule. So that's probably a little easier. Oops, I think I forgot a bracket here. All right, y prime equals, we'll do the cosine of 1 over x plus 2. And then to take the derivative of the second part, we'll pull the negative 1 down in front. It's being multiplied. I need it in parentheses because I don't want it to look like it's being subtracted. Times x plus 2 raised to the power of negative 1 minus 1 is negative 2 power. And then times the derivative of the inside function x plus 2. But guess what the derivative of x plus 2 is? Just 1. So it's pretty well done now. You cannot leave a problem with a ddx in it still. Even though we're not simplifying, all derivatives must be taken in order for the problem to be done. You would not need to write times 1, but you would need to show that you finished taking the derivative by carrying it forward one more step. All derivatives must be finished, even if it says you don't have to simplify your answer. All right, we're on the last problem, number 17, but it's a 3-parter. And it says if h of x is equal to f of g of x squared, use the values in the chart to answer the following. A, what is h of 1? Okay, so h of 1 would equal f of g of, instead of the x, it's 1 squared. And I've got to get all the brackets and parentheses matched up here. And we are going to work this out using the values in the table. So 1 squared is 1, so we're going to do g of 1 here. You look for the g of x, and then you look for the x of 1, and that's 4. So that's f of 4. And then f of 4 is 8. So h of 1 equals 8. That's the answer for part A. Next, we're going to go B. What is h of 2? Okay, h of 2. h of 2 is equal to f of g of 2 squared. Close that, bracket that. So the inside is 4. F of g of 4. G of 4 is 1. So h of 2 equals f of 1. And then f of 1 is 3. So h of 2 equals 3. And that one is now done. All right, now we're on the last one where we actually get to do some calculus and not just algebra. We're going to take the derivative of h of x and then sub in 2. H prime of 2 means first find the derivative of h of x and then substitute in 2 for the x's. So f of g of x squared is our function, and we have to take its derivative. So we'll start with the derivative of the outside function, f. The derivative of f is f prime. Copy the inside function, multiply by the derivative of the inside function. So now everything in front, I'm just going to carry forward in front, not change anything. To take the derivative of g of x squared, I'll start by taking the derivative of the outside function, g, which is g prime. Copy the inside function, x squared, then take the derivative of the inside function x squared, which is 2x. And now we are done, because that's no longer a composition of functions. So now we're going to sub in 2. H prime of 2 is f prime of g of 2 squared times g prime of 2 squared times 2 times 2. Oops. Okay. So now h prime of 2 equals f prime of g of 4, g prime of 4 times 4. So now we're going to pull values from the table. Follow order of operations, work inside the parentheses first. G of 4 is 1. So this will be f prime of 1. G prime of 4 is negative 1/2. So negative 1/2 here times 4. F prime of 1 is 2/3. So 2/3 times negative 1/2 times 4 is negative 2. And negative 2 times 2/3 is negative 4/3. So the answer is negative 4/3. Kind of had a difficult time fitting that here, but I somehow squeezed it in. Hopefully you can read that. Negative 4/3. So that is our fun continuation of our chain rule lesson. Hopefully you feel very well prepared for what is ahead, because this was our last lesson of this unit, and we will also be working on our review. So have a great day, and I will talk to you soon. Bye.